Let's practice solving a quadratic trigonometric equation that uses trig identities as well. And while there could be an infinite number of solutions, we are just going to be looking for the ones that lie between 0 degrees and 360 degrees. And when it comes to rounding, let's just go ahead and make sure we round to the nearest tenths place to stay consistent. Right away from the beginning, we want to notice that we have a sine function as well as a cosine function, so hopefully we can use a trig identity to get them both to be either sine or cosine. Alright, so to begin, I'm just going to copy down this equation. So we have -3 multiplied by sine squared of theta plus this cosine of theta plus 1, and that's going to be equal to 0. So the first thing that jumps out to me in terms of trig identities is going to be this sine squared of theta. When I see this sine squared of theta, I think about this Pythagorean trig identity where sine squared of theta plus cosine squared of theta is equal to 1. If you go ahead and rearrange this identity and subtract cosine squared of theta from both sides and move it to the right side of the equation, you'll see that sine squared of theta is equivalent to 1 minus cosine squared of theta. Let's go ahead and use this expression of 1 minus cosine squared of theta and substitute it in for sine squared of theta. If we go ahead and do so, we're going to have -3 multiplied by 1 minus this cosine squared of theta. Then we're going to still have this plus cosine of theta plus 1 is equal to 0. Now to clean this up a little bit, I'm just going to go ahead and distribute this -3 to both terms inside this parentheses. -3 times 1 is going to be -3. -3 times this negative cosine squared of theta is going to be plus 3 times this cosine squared of theta. Then we still have this plus cosine of theta and plus 1 that we haven't used at all. Then by combining like terms, we can add this -3 and 1 together and write this in standard form. We have 3 times this cosine squared of theta plus 1 of these cosine of thetas, and then -2, and that's going to be set equal to 0. Now that we just have one trig function, we have cosine and cosine, let's go ahead and use some u-substitution to solve this like a quadratic equation. Using u-substitution, let's go ahead and let u represent this cosine of theta for the time being. Making some substitutions, we're going to go ahead and just write that we have 3 multiplied by u squared. That's that cosine of theta times cosine of theta. Plus we have just 1 cosine of theta, so we're going to put 1u, then -2, and that's set equal to 0. Now, while some trinomials are factorable, unfortunately this one's not going to be. So you can use some different strategies, but I'm going to go ahead and use the quadratic formula to solve this quadratic equation. So since this is not going to be factorable, let's go ahead and use the quadratic formula where a is going to be equal to 3, that leading coefficient, b is going to be equal to 1 since we have 1u, and then c is going to be equal to -2, that's that constant term. So in case you forgot, this right here is our quadratic formula, so we can go ahead and plug in our values here. So we're going to have this -1 plus or minus the square root of 1 squared, that's just going to be 1, minus 4 multiplied by 3 times -2. And this whole thing is going to be on top of 2a, so 2 times that 3 is going to be 6. Now if we go ahead and multiply this -4 by this 3 and -2, I believe that's going to be, I think, positive 24. So we're going to have -1 plus or minus, and then 1 plus that 24, that's going to be 25. So that's nice because that's a perfect square, and that's going to be over 6. And so square root of 25 is 5, so we have -1 plus or minus 5 over 6. If we go ahead and solve this, -1 plus 5 is 4, so we have 4 over 6. But then if we take -1 and take away 5, that's -6, so we have -6 over 6. So for our two solutions here, we're going to say that x would equal 2/3 if we simplify that 4/6, as well as -1, since -6 over +6 is equal to -1. Okay, so I know I just used the quadratic formula and then I use this variable of x, so we have x is equal to 2/3 of -1, but hopefully that's not too confusing that I'm using x in place of u. So I know it's like a lot of substitutions here, but these x's are essentially the same thing as that u. I just didn't know if that would be confusing using u in the quadratic formula. So writing our solutions down, we can say that u is going to be equal to this ratio of 2 to 3, or 2/3, and also u is equal to -1, okay? Now let's go ahead and remember what u represented. This u we said in the beginning was really just representing this cosine of theta. So let's go ahead and swap that back and say that cosine of theta is going to be equal to this ratio of 2 to 3, as well as cosine of theta is equal to that ratio of -1 to 1, or just -1. Now we can go ahead and use our arc cosine function. If we want the angle, we say theta is equal to the inverse cosine, or arc cosine of 2/3. And then we can also say for our other one that, or another equation here, that theta would be equal to arc cosine of -1. All right, now if we go ahead and plug this into a calculator, because that's not going to be a very nice number here in terms of what we can write. So we have theta would be approximately equal to 48, we're going to the tenths place, so 48.2 degrees. Now remember, we are looking for solutions between 0 and 360 degrees, so we like this one. Now for arc cosine of -1, you technically don't need a calculator for this one, it's on the unit circle. So remember, cosine is the x value, and the only location where the x value is -1 on the unit circle is at exactly 180 degrees. Now of course, if you already have a calculator, you might as well plug it in just to double check that, but that is going to work, and it's also between 0 and 360 degrees. So we have two solutions here, but I think there is one more still hiding that we need to find. Let's go ahead and use the unit circle to help us out over here. So taking a look at this 48.2 degrees, I'm going to go ahead and draw a reference angle here. So slightly past 45, maybe something like this. And I'm going to go ahead and draw our triangle, just because I find that kind of a little bit easier to kind of comprehend here. So there's theta, our 48.2 degrees, and our ratio here is 2 to 3. Now cosine is always going to be that adjacent over hypotenuse, also known as x over r, okay, or x value over the radius. So the 2 would be the adjacent side, so 2, it's a positive 2 in quadrant 1, and 3 would be that radius of the circle. So not exactly the unit circle, but the ratio is 2 to 3. Now, we have a positive ratio here just because cosine is positive in quadrant 1, but think about where else is cosine positive. So we've a positive 2/3. The only other location where this one would be positive would be over in quadrant 4, where cosine is also positive. So we have to go ahead and draw another 48.2 degree reference angle over in quadrant 4. So if you take a look just like this, our theta of 48.2 degrees would be right over here. Okay, and our ratio here is still going to be 2 to 3, since this value is 2, and that adjacent, or that x value here, is still 2 across here. Okay, so we already have this 48.2 degrees, that's right over here. But what's this angle measure all the way around? Well, if we go all the way around in this direction, since we need an angle between 0 and 360, this would just be 360 take away the 48.2 degrees. And so 360 degrees take away that 48.2 degrees is going to be 311.8 degrees. This would be the third and final solution for this equation. Now real quick, if you're wondering why we don't have another one for this ratio of -1, let's try to see where -1 is on the unit circle. Remember, cosine is where the x value is, so right over here to the left, this is -1, 0. And there are no other angle measures that are going to get us that x value of -1, because that's the furthest to the left that this point can go. All right, so putting all three of these solutions together here, we can say that our theta is going to have three solutions between 0 and 360 degrees. Our first one we found was 48.2 degrees, and then we went ahead and used the same ratio to find out another angle measure that got us that ratio. So that's going to be 311.8 degrees. That was 360 minus the 48.2. And then finally we had that 180 degrees for that ratio of -1, and there was only one location where that could happen. Alrighty, so there you have your three different solutions for this particular trig equation. And if you found this video helpful at all, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.